Let's have a look at exercise 4J. This is in the IB Maths Oxford book, Applications and Interpretation, standard level. 1. In a town, 3 schools, A, B and C, are located at the points with these coordinates. It is decided that a new school should be built as close as possible to a point which is farthest from all 3 existing schools. A. Explain why this point will be at the intersection of the perpendicular bisectors of line segments AB, BC and AC. Well, this comes from the book. A point at which cell boundaries meet in a Voronoi diagram is called a vertex. A vertex is equidistant from the 3 surrounding sites. All right, so that's A, B and C. Just jumping ahead a bit here, and that's where it is there. That's the vertex. B, find the equations of the perpendicular bisectors of line segments AB and BC. I've already done AC. We found the first step is to find the midpoints. We can find the midpoints because we know the points. The midpoint is the average. So we've got the A and B. So that's 1 plus 6 is 7 divided by 2 is 7 on 2. And 3 plus 4 is 7. And divided by 2 is 7 on 2. Similarly, B and C, we've just added up the 6 and the 6 and divided by 2, and we've got 12 on 2, which is 6, and the 4 and the 1 divided by 2, and that's 5 divided by 2, and similarly we did the same here. So we've got the midpoints. Once you get the midpoints, you need to find the gradients, and the gradients we just use our y2 minus y1 over x2 minus x1. It doesn't matter which one you start with, but for example, AB here, okay, we're going to do the 4 is y2 minus y1, 4 minus 3, and then we're going to do x2 minus x1 would be 6 minus 1, and that's 1 on 5. Okay, we've got one which is undefined here because it's 6 minus 6 with 0 on the bottom, undefined, so that's a vertical line. And then we did the same for AC using the points A and C, and we found out it was minus 2 on 5. Once you find the gradients of the lines that connect each site, we then find the perpendicular gradients. The perpendicular gradients is you change the sign and you invert it. So 1 on 5 becomes minus 5, undefined becomes 0, and minus 2 on 5 becomes 5 on 2. So it's inverted and change the sign. Now I've put these in colour. So once you do that, then we use our point gradient form. And we've got y minus y1 equals m times x minus x1. And the points have just come from here. So we use the midpoint because we know that's on the line of the perpendicular bisector, and this is the slope of the perpendicular bisector. And these are our 3 equations here. C, hence find the coordinates of the point where the new school should be built. Well, at the intersection of those lines, and they all intersect at the same point, but we're just using A, B and BC. We're saying that at that point, the y values and x values are the same, so y equals y. And so if y equals y, we can just we're going to use a, b, and bc. So that means y minus 5x plus 21, right? Minus 5x plus 21 equals 5 on 2. We resolve that to this, x equals 37 on 10. Now that's 3.7, okay? And that gives us the x value. We have to find the y value, so we put it back into any of these 3 equations. We use these 2 to find it. So, well, we can't put it in that one, but we can put it in this one here. And we put x in here at 3.7, and we find that y is equal to 5 on 2. So the point is 3.7 and for x and 2.5 for y. D, determine how far the new school will be from each of the other schools. Well, it's equidistance from each school, so we're going to just use one of the schools. I've chosen A, and that's at 1, 3. So we're going to look at the distance from there to there, and we're going to use the distance formula, which is D equals the square root of y2 minus y1 squared plus x2 minus x1 squared. Okay, and so the points we're using is the school A and also the vertex point, which we just found over here, 3.7 on 2 and 2.5. And that's that. And then it resolves down to 2.75 units. It says in the book it's kilometres, but there's nothing in the story to say it's kilometres. So I've put it as units to 3 significant figures. Question 2. At a fair, there are 3 hamburger stands, A, B and C. The fairground is in the shape of a rectangle with dimensions 100 metres by 50 metres. The bottom left corner of the field can be regarded as the origin of a coordinate system, with the diagonally opposed corner at 150 at the point 100. X is 100 and Y is 50. So that's that point right there. So that's this area here, the purple rectangle. The hamburger stands are at these points. So I've located those at A, B and C. Find the equations of the perpendicular bisectors of. So this is very similar to question 1. Now they're only after A and C and B and C. So A and C, we're looking for that equation of that line, and B and C, we're looking for the equation of that line. First thing is to find the midpoints. Well, we find the midpoints by using the average. So the average between A and C is 20 there plus 40 for the x's divided by 2. That's 60 on 2 is 30. And 30 is, A and C. 30 and 10 is 40 divided by 2 is 20. We did the same for B and C. Once you find the midpoints, you find the gradient. The gradient, A and C, it's going to be a negative gradient there. It's we're using A and C, so we're using this point and that point. Well, the gradient is y2 minus y1. That's 10 minus 30 on the top. And 40 minus 20, x2 minus x1 on the bottom. And you've got minus 1, similarly with B and C. Okay, using B and C for this one. Once you find the gradient, you know the perpendicular gradient. The perpendicular bisector gradient will be the opposite sign and inverse. Well, that will be 1. Opposite sign inverse of this is minus 2. We then use this information here plus the midpoints, so the perpendicular bisector gradient and the midpoints, into this formula, the point gradient form, which is y minus 20, y minus y1, and we use the slope of 1, x minus x1, and over here is y minus 20, y minus y1, times the slope, which is minus 2 times x minus 60, and we get y equals x minus 10, and y equals minus 2x plus 140. Remember these equations here, this one is AC, so that's the equation of this line. We expect it to be positive slope, and it is. And this one here is BC, so this one, which we expect to be a negative slope, which it is. So they're the equations of those perpendicular bisectors. B, people will always go to the hamburger stand that is closest to them. B, draw the Voronoi diagram that represents this situation. Okay, so we've got one more line to draw, and that is the perpendicular bisector between A and B. Well, perpendicular bisector to the line AB, and that is the vertical line that goes straight up here, 50, right? So it's on y equals 30 and x equals 50. So it goes straight up there. Now, so I've written that in here, you can see that, or drawn that there, you can see that there. Okay, so how do we use that? Well, we're going to do it all by eye again, and we're going to break this thing up. All this area in here is closer to A than it is to C, so we can colour all that in one colour. This line separates A and B, so we can go right up to that line in that corner up there, and we can fill that in as yellow as well. C now is all this area from this line down this way, but it's not in this area because that's B. So C goes up there, and between C and B is here, so that cell is C. B is everything on the right side of that line, or this side of that line, all of that up to the border here, and because this area up here is the difference between, is the line that separates A and B cells, it's also that part there. Okay, great. Let's have a look at C. Find the region of the fairground which is closest to stand C. Well, stand C is here. Okay, it says find the region. So they're actually asking for the percentage of the entire area. How much of that area is cell C or region C? This area here. So I took the area as a triangle. I've used that as the base, which is 70 minus 10 as the base. So it's half the base times the height. The height I've taken as 40, and I got 1200. The percentage of the area is 1200 over 5,000 because the whole area is 50 times 100. That's 5,000. So I put 1200 over 5,000 multiplied by 100%, and that's 24%, or as the book says here, 0.24. Now with stand A, I did the same, but I actually broke it up into 3 parts because I had to work out what the area of this was. So I broke it up into this top part here. Okay, that's 10 by 50. Okay, this part 2 is 10 by 40, so that's 400. So we've got 500 plus 400. Now the area of this triangle here, it's 40 by 40, so it's a half the base times the height, and that's 800. Okay, because that's 1600 on 2, and then we've got 1700 as a percentage of the area. That's 1700 on 5,000 times 100, that's 34%. And they've got 0.33 here in the book. D. A 4th hamburger stand is to be added. to the fairground at a point as far as possible from the other three stands. State the coordinates of the position at which it should be built, or at the vertex it should be built, which is at 5040 right there, because that's the equidistance from the other hamburger stands. 2, determine how far the new hamburger stand will be from the other hamburger stands. We only have to use one of these points, either A, B, or C. I chose stand A, and that's at 2030, and the vertex is 5040. I use the distance formula, y2 minus y1 squared plus x2 minus x1 squared, using these 2 points, stand A and the vertex. I could have used stand B or stand C, and we found the distance to be 31.6 meters to 3 significant figures, and that was okay.